Hello students, welcome back. So now we are going to be learning about AWS Bedrock. Specifically, we'll be learning Converse API, multi-turn conversation, and tool assistant. AWS Bedrock, it is a cloud-based service. It helps you build Gen AI applications with a minimal amount of code. Also, using API, you can access the top-end model of this Bedrock. So the Bedrock, it provides you features like knowledge bases, guardrails, and agents. And you don't have to manage any server or infrastructure. So let's start with Converse API first. So let's go ahead, type Bedrock over here, Bedrock, and you're going to see these options right here. We are going to be using this one, Amazon Bedrock. Go ahead, click on this. And this will take you to this screen right here. So go ahead, click on this playground over here. And that will take you to this screen. Now it's going to ask you, select a model to get started. So let's go ahead and select a model. Click on select model. And in this particular instance, I'll be using Amazon right here. You have a bunch of other models. You can choose Amazon, Anthropic, DeepSeek, Google, Meta. You have a lot of models over here. Over the years, they keep adding some more. In this case, for demonstration purpose, I'll be using Amazon. I'll be using this one, Nova. You know what? Let's go with this one, Nova 2 Lite. This one actually is a little bit cheaper. And then go ahead, click on apply. Now on this page, you can chat with your model. So let's say you want to ask, what is serverless computing? What is serverless computing? And you can hit enter, or you can just say click on run. That's going to give you the response. All right. So you can talk like this. This is one way. Also, I want to show you something about this settings right there. You can actually change your model. If you come over here, and you're going to see this is your model right here. You can even add a system prompt. And if you want to change this model, go ahead, click on this. And you can go back and select any one of these models, whichever you want. Now, system prompts over here, it is used to define model's role and behavior. And then there are also other parameters that you can control. For example, built-in tools, model reasoning, length of your token, randomness and diversity, guardrails, and so on and so forth. And now I'm going to show you how to make an API call using Bedrock's Converse API. First thing you do is install Pt1 and Python.env package. And the way you install this package is by running this command right here. Now make sure that you put your AWS credentials, meaning your AWS access key ID and also your AWS secret access key in this .env file. Then I'm importing my Pt1. By the way, Pt1 is the package that allows your program to communicate or to make API calls AWS framework. So I'm importing my Pt1. I'm also importing OS. Then I'm loading the environment file. And this is my AWS access key. I'm accessing that key. I'm also accessing the AWS secret access key. Now this is the function I'll be using. Use Converse API. In this case, first thing I'm doing is creating a client. The service I'll be using would be Bedrock runtime. The region would be US East 1. Also supplying my AWS access key ID and also AWS secret access key ID in order to create a client. The model that I'll be using would be this one, Nova Lite v1:0. Then let's define a system prompt. So essentially this defines model behavior. So in this case, I'm saying that you are a helpful technical assistant, explains the concept clearly and concisely. So this is the system behavior. This is the model behavior. User message. This is what the question that goes to the large language model, to this model. So in this case, I'm printing out the system prompt. I'm also printing out the user message just to display what the user is asking. Now let's use the Converse API. So in this case, this is how you make a call. This is how you do API call. Supply your model ID. Give your system prompt. My model ID is over here, this one. System prompt is this one right. Then you give your message. So message is role would be user. Content would be text. User message. User message would be this question. What is cloud computing? All right. Also supply your inference configuration. So the temperature I'm specifying is 7 and the maximum token limit I'm giving is 2000. I just don't want it to keep rambling and waste unnecessary tokens. That's all. From the response that you see from the AWS Bedrock, extract the text. This is how you extract the text right here. By the way, some of you might be wondering, how do I know all this thing? This is actually, you can get this thing from the documentation, from the SDK documentation. That will tell you this is how you read the text. printing out the output text right here. Also, want to know the token use. In this case, you also can access the usage right here. From the usage, I'm accessing input tokens, output tokens, and the total number of tokens. And then I'm also printing out what is the reason it stopped. If everything goes fine, it's going to print out this thing. Otherwise, it's going to print out the error message or the error message. After this, I'm calling the use Converse. Now let's go ahead and run this. Come over here, run Python file, size of this, C. All right, prompt, so it prints out the system, out the user message. Now it gave me what a cloud computing. Here you go. Assistant response. Cloud computing is the delivery of computing services such as servers, storage, databases. All right. It gave me cloud computing. Also, I was printing out the 19. The output token I received from my large language model total is 474. Top reason and done. Great. My Converse API is. Now I'm going to show you how to perform multi-turn conversation. In other words, this will allow large language model to remember the previous conversation. So this way, the whole conversation will seem like one seamless conversation. So importing my Pt1 like I did before. Also I'm importing my OS so that I can load my environment variables, just like I did before. Okay, so I'm defining this function called multi-turn conversation. So create a client right here. Service I'm using would be Bedrock runtime, same as I did before. Then US East 1, that's my region name. Also supply your AWS access key ID and also your secret access key. Model ID that I'm using is this one right. Give you a system prompt. In this case, my system prompt is that for an expert AWS certified solution architect, professional, and an elite technical instructor. This conversation history, I'm creating an empty list. So this is how I'm going to previous conversation. I'm going to be asking series of questions. I think 3 questions. And so each time when I get the response, I'll be taking the response and the question, applying it back to my large language model along with the new questions. This is how to simulate a conversation history. Okay. So question number 1, the user asks for academic related suggestions, something like this. Let's say the user asks this question. I'm writing a master thesis on a genomics and have 500 GB data set. What AWS storage and analytics tool should I use to process this on a student budget? This is my first question. Suppose print out the then my conversation history. I'm appending the user role, also appending this user message right here. Then using the client, I'm calling the Converse API, apply your model ID, supply your system prompt, also give your conversation history. This is what the technique I'll be using to remember the previous conversation. Also give your inference configuration. So in this case, my inference temperature would be 7. Also maximum token I'm saying 2. So I get a response. This is my first response. I'm printing out the response. Then what I'm doing is I'm taking the conversation history, the empty list, and I'm appending that. I'm adding some more, adding the role assistant. I'm also adding the assistant message. Okay. After this, I ask the next question. Then I ask for modification. Okay, so you get a response initially, and from the response I get from the large language model, I'm asking modification. And the question is, things that make sense if my university requires all raw patient data to remain strictly within European boundaries compliance. How does that change the architecture? This is my second question based on what I receive. By the way, I know what's going to be the type of answer I'm going to receive. Based on that, I've already made this question. Right? Real world, you'll be actually creating a while loop. So you'll be asking questions using a while loop, and based on that, give you a response. Okay, so creating a conversation history, I'm appending the as a user, giving the text with the user message. Then I'm asking the Bedrock client, okay, the API, the Converse API, it's going to send the. And now this is how it's going to take all previous conversation and it's going to give it to the Bedrock client. I get the response back, printing out my response, and then I'm creating another. I'm actually adding more stuff to the conversation history. I'm adding role assistant and whatever response I received from the large language, adding that over Okay, then I'm asking the third question. The user is asking for cost information. Maybe he wants cost. In this case, this user message is how much, and I'm printing out the user conversation history. I'm adding user, adding the text user message. That would be the, then I'm sending this, making an API call. Same, everything is essentially same as the previous one, and get the response. If I get the response, I actually also printing out total usage, how much token was for my stats. Just keep an eye on this. All right, and then in the end, I'm running this return. Let's go ahead and run this. Let me increase the size of the screen so you can see. Come over here, run Python file, wait for it. There you go. The ask academic related size of the screen. See, there you go. First question asked right here. It says user, I'm writing a master thesis in genomics, and this is the question he asked. Instant, and he received this answer from the AWS Bedrock. It's not print out everything because my limit, if you remember, I put a limit of 200 maximum. The limit over here, 200 tokens. That's why it's not full answer, it's part. Then I'm asking it some more, take some more. In this case, I'm saying that makes sense if it's all raw patient data. So this is the follow-up question, the answer that I received. Hey, then I received this response from your large language model. It's great. Now I'm asking another information. This is another follow-up question. I'm asking it to give cost information. I never, like in this, and telling it, give me a cost information for that project. What's happening is that it's remembering that conversation I just created. Each time when you pass the previous messages, you append those previous messages along with the question. This is how your large language model, this is how you accomplish the memory part. Okay, and then at the end, I'm printing out 500 output. Right. Now we are going to create an assistant. This assistant will be using tools. Allow your AI model to communicate, to actually perform some action. Maybe it can make some API call, maybe it can grab some data from a database, or maybe it can actually go on the web and do certain things. It allows you to perform some actions. These are nothing but simple Python function. That's what they are for them. So I'm importing JSON, importing Boto, and importing request. Loading my environment variable just like I did before. And I'm defining this function called getWeather. This is the tool that would be called. So in this case, it actually fetches the weather data for a location. Geo URL, user is going to supply the location. First thing I'm going to do is get the geolocation. After I get the geolocation, I'm going to get the weather, the geolocation. So this is the API call that will be made over here. There will be essentially there will be two API call made inside this get weather. Okay, and then at the end is return location, temperature, condition, humidity, and wind speed. All right. Then back down over here, supply your tool configuration, basically the metadata about this is how you need to do this on AWS Bedrock. Specification, this get weather, description, write a description about your tool. Your input, in this case, this is JSON type, properties, location is a string, description, location means all can be Fahrenheit and Celsius. Write a little description over. Mandatory locations. Then my create a tool function, the list of dictionaries, get weather, and this is get weather. Now let's define our the one that's running it. So you give your tool functions, get your function, get un. Okay, then let's create a demo tool, a demo function. This is responsible for using the. I'm creating a Bedrock client. This is a Bedrock run. specify your access. Then give your model ID. The user message is this. What is the weather like in Seattle right now? Back down, create my message, sending the message to the model with definition. Give this message, whatever the user typed, also giving the config, this one. This config, there you go. Tells you that's the large language, which to. Okay, so also supply your inference config. Same thing I did before. This time I'm saying my temperature is 0. I want same consistent answer every single time. I don't want it to change the answer from one run to the other run. That's why I'm specifying my temperature as 0. Okay, I'll also specify my maximum number. Then right here, I'm actually model response stop region. Stop region, let's say that model has to stop region is tool. Then in this case, getting the tool name, I'm getting the tool, getting the tool user ID. Then I'm writing a little message over here. Model wants to whatever the tool. Then I run the tool, and it returns when it runs the tool. In the word, it runs that get weather function. Return a value. Whatever value, whatever temperature I get, that would be. There you go. To return this particular data, right? Return the location, temperature, location. Okay. So, okay, so I get the result right here. Then what I'm doing, taking the message, appending it to the assistant message. Sorry, I'm appending the assistant message to the messages. I'm also appending the message, right? In this case, giving the tool ID or JSON result. Then sending all this information back to the your model now. ID message would config would be this. I get the response back. At the end, let's go ahead and run this. So just come over here, go ahead, Python. There you go. Question that I asked was, what's the weather like in Seattle right now? Sending the message definition. Ran the function that gave location, Fahrenheit. Now all this result, it went back to the model. Then the model took this value, gave an answer in natural language. And it says the weather in Seattle is clear with partly cloudy skies. The temperature is this, the humidity is this, and this. Essentially, all this information. The difference is now is printing it out in a more readable form.